Awesome. Today we're going to talk about central and inscribed angles mainly, but also a couple things to do with the arcs of a circle and stuff like that. So let's go ahead and get started. Okay, so first of all, what is a central angle? A central angle is on a circle, an angle whose vertex is the center of the circle. And again, what does an angle look like? Start with that. So an angle looks like this. It's made up of two rays. They meet at one point, and this one point right here is called the vertex. So the vertex of the angle would be the center. For example, angle ABC. Okay, so this is a central angle. And down here it also says that the measure of this central angle, ABC, is equal to the measure of the arc, AC. So let's give an example. Let's say that this angle right here on the central angle, ABC, is equal to 50 degrees. This was 50 degrees. That means that the arc, AC, is also 50 degrees. Okay, this can be with any number really, so let's get through it again. Let's say that the arc this time is 115 degrees. What does that mean that the angle is? It's the same, so also 115 degrees. Okay, so that's the basic part. Let's see what an example looks like. Okay, so we want to find the measure of each arc. Okay, so first of all, arc BC, well arc BC is right here, and it's giving us that this central angle is 32 degrees. That means that the arc is 32 degrees. Arc BD all the way around, I'll go ahead and draw it, from B all the way around to D. It's going to be BC plus CD. So these two arcs together, so we're going to say 32 plus 58. We end up getting 90. So we get 90 degrees. Okay. The next arc, ABC, it's named with three letters, meaning it's going to be either a half circle, semicircle, or a major arc, which is more than 180 degrees. So let's look at ABC. So we have A, go ahead and use a green on this one, from A all the way around the circle. My drawing is not the best. From B, and then we keep going to C. Well, how in the world were we going to find this? If I know what BC is, and if I knew what AB is, all I could do is just add them up. The problem is I don't know what BA is or AB. I don't know what the arc AB is. If I knew what this is, I could just add them together. Since I don't, I got to think of something else to do. So in our vocab, we also knew that there was what we called a semicircle, and a semicircle is half the circle. Well, I have this segment from C all the way to A that goes through the center. It's a chord that goes through the center point, so we're going to call this the diameter. If we're going from one side of the circle, or one part of the diameter, all the way around to the other part of the diameter, we're going to call this a semicircle, half a circle. And we know that a semicircle is half, so 180 degrees, because a full circle is 360. So we just take 360 divided by 2, we get 180. So 180 degrees right here. Okay, so that would be ABC. A to B to C, half the circle. To find AB now, AB, well, we knew this whole thing was 180, but I don't want the whole thing. I just want from A to B, this portion of it right here. Again, my drawing is not that great, but we just want that portion. So we're going to subtract off BC, and BC was 32 degrees. So subtract that out. 180 minus 32, you end up with 148. So it's 148 degrees. Okay, so this is all about central angles, if the vertex is in the center. So what if it's not? There's another thing that we call inscribed angles. What is an inscribed angle? Well, it's where the vertex of the angle is on the circle. See this angle, ABC. This vertex is on the circle. It's called an inscribed angle. Okay, and we know that the inscribed angle, angle ABC, is equal to half the intercepted arc, or half of AC. So let's give an example. Let's say that the arc is 100 degrees. If we're saying that the angle, the inscribed angle, is half the arc, 100 divided by 2, or half of 100, is 50 degrees. That's what this arc, or this angle would be. Let's say we know the angle. Let's say we know the angle to be 120 degrees. What would the arc be? Well, if the angle is half the arc, that means the arc is twice the angle. So 120 times 2 would give us 240 degrees for the arc. So let's go ahead and look at an example. Okay, so this says that the measure of angle ADC, ADC, is 152 degrees. Well, this is a central angle, meaning that the intercepted arc is the same. So this is also 152 degrees. Okay, but I want to find this angle, ABC. So how do I find this angle right here? Well, I know that this is it's in arc, or including this arc, AC, 152 degrees, and it's an inscribed angle on the circle. We know that the inscribed angle is half the arc. So if the arc is 152, we just divide this number by 2. So 152 divided by 2, and we get 76 degrees. Okay, so this angle is 76. And that's what angle ABC is, 76 degrees. We already found the arc AC. It's 152, the same as the central angle. And the arc ABC. This is an interesting one. It goes from A all the way around to B, then keep going to C. It's all of this portion of the circle. It's actually the whole circle except for the arc A to C. Well, again, the whole circle is 360 degrees. A to C is 152. That's something we don't want. So we're going to subtract out 152. So we get 360 minus 152, and we get the total of 208. Meaning the arc A to B to C, the rest of the circle, is 208 degrees. Okay, so we did get homework on this, so I'm going to go over some of the examples on the homework. Okay, the first one being number 2. So this one, it says in circle O, RT is parallel to YZ. They're parallel to each other. I'm going to go ahead and draw the symbol on here for parallel, and again, the symbol looks like a little arrow. Okay, those mean that these are parallel to each other. And what does that mean? What kind of information can we get out of them being parallel? Well, if they're parallel, that means that this arc, TZ, and this arc, RY, are going to have to be the same because they're exactly the same distance apart. So this is congruent to this, TZ being congruent to RY. So why do we care about that? Well, ZY is the diameter, meaning that Z all the way around to Y, the arc Z, let's call it ZTY, this arc on the left side, is going to be a semicircle, meaning 180 degrees. Okay. If I know that TR is 50, I'm going to subtract out 50 to get 130 degrees. And that means that TZ and RY, whatever's left over, is both of those. Okay, so 130 is RY and TZ together. But if each one is congruent, we can just divide it by 2 and get 65 degrees, meaning RY is 65 and TZ is 65. So that's the answer to the first one. Measure of TZ is 65 degrees. And the measure of angle TYZ. TYZ. What angle is that talking about? It's talking about this angle right here, TYZ. And again, this is on the circle, so it's called an inscribed angle on the circle. And we know that an inscribed angle is half the intercepted arc. Well, this is the angle we're talking about. Okay, so the intercepted arc is this arc right here. If the arc is 65 degrees, what's half of 65 to find the inscribed angle? 65 divided by 2, we get 32.5. Okay. The next example, this is actually number 7 on the homework. Okay, we see the circle and we see this angle right here. I'm going to call it PNM. PNM, or just angle N right here, this angle. This is another inscribed angle, which is going to be half the intercepted arc. The problem tells us that angle N is 38 degrees. So this is 38. If the angle is half the arc, that means the arc is twice the angle. So to get the arc, we multiply the angle by 2. So 38 times 2. And 38 times 2 gives us 76, meaning the arc MP or PM is 76 degrees. Okay, the next example is number 9. It's telling us that the measure of BD, arc BD, all the way across this whole thing is 90 degrees. The measure of angle 3, I'll put it in blue, that's red, is 25 degrees. Okay, those are the two given parts of information. It wants us to find the measure of arc BC and find the measure of angle 4. So I'm going to start with the arc BC. Well, how do I find this? Well, if the angle, the inscribed angle is 25, we just multiply it by 2 to find the arc. So 25 times 2 is 50, meaning BC is 50 degrees. Okay, the next thing, to find angle 4. Well, if I know BC is 50, I know BD, this entire thing is 90, so I say 90 minus 50, I get 40 degrees, so CD is 40. And to find the angle, the inscribed angle, you just divide the arc by 2, so 40 divided by 2. And we end up with 20 degrees. So angle 4 is 20 degrees. Okay, I understand that this 20 degree angle looks bigger than the 25 degree angle, but that's just because this picture is not drawn to scale. Okay. There are a couple other things that we talked about or we need to learn. We're going to look first at this picture and see what we can come up with, and then we're going to reveal what the theorem is. Okay, so first of all, I want to look at this arc all the way around, from A all the way around to C. I'm going to actually put another point over here. Let's call it point D. The only reason I'm going to do that is so I can name that arc. So ADC, the arc ADC is half the circle, which means that the arc is 180 degrees. Half a circle or semicircle, 180 degrees. Well, this angle, angle ABC, is an inscribed angle because it's on the side or on the circle. The inscribed angle is half the measure of the arc. So if the arc is 180 degrees, what's the measure of the angle? The angle would be half of 180, which is 90 degrees. So there is a theorem that says this, and the theorem says an inscribed angle, an angle that's inscribed in a semicircle, is always going to be a right angle. So this one's always a right angle. It's always going to be true. Okay, so the measure of ABC is 90 degrees. So let's see an example of this. Okay, this one's one of our homework questions, number 6. So if we notice from A all the way around to B, this is a semicircle. Okay, meaning 180 degrees. Okay, well this inscribed angle is including this arc, 180 degrees, so you divide the arc by 2, so 180 divided by 2 is 90, so angle C is 90 degrees. And again, that was our theorem. It said if it's a semicircle, it's always going to be 90. Okay. The arc ACB, well, A to C, all the way back around to B, it's a semicircle, half a circle, so the arc is going to be 180 degrees. Okay. The next theorem, I'm just going to give this to you. It says the opposite angle of a quadrilateral, the opposite angles of a quadrilateral on the inscribed in a circle are always going to be supplementary. Remember what supplementary means? Supplementary means add together to make 180. This says opposite angles, so meaning angle A and angle C add together to make 180 degrees, and that's where this thing comes from. A and C add up to 180. Opposite angles are supplementary. Again, on the other side, B and D, opposite angles, they are going to be supplementary. Okay, so let's look at an example. This is number 4 in the homework. It says that measure of angle A is 110. The measure of angle M is 65. So I want to find the measure of angle K and the measure of angle R. Well, again, this is a quadrilateral inscribed or inside the circle. That means opposite angles are supplementary. So measure of angle A plus the measure of angle K has to equal 180. These two across from each other have to equal 180. So how would I find this? Well, the easiest way to do it is if I know they both add up to 180, just say 180 minus whatever angle I know. So 180 minus 110, which is 70 degrees. So K has to be 70. Similarly, on the other side, M and R have to add together to make 180. So I just say 180 minus 65. And 180 minus 65 gives us 115 degrees. And that would be the measure of angle R. There's another question like this on our homework. It's number 8. It only tells us part of the information. It says angle M is 122 degrees. Can I find the rest? Well, sure I can. First, I'm going to start with the measure of angle P. So how do I find this one? Again, quadrilateral inside the circle. So opposite angles are supplementary. So I say 180 minus 122, and I get 58 degrees. Then how would I find the arc from S around to P and around to A? Again, my drawing is not very, it's actually terrible. Let's try again. Okay, from S around to P and around to A. It's a little better. So this arc all the way around. Well, if you look at this, the angle SMA, I'm going to go ahead and highlight it. S to M to A, this angle right here, it includes this whole arc. This angle M, or SMA, 122 degrees, is an inscribed angle, meaning that it's on the side of the circle. Okay, so to find the arc, you just multiply your inscribed angle by 2. So we say 122 times 2, and we get 244. So that would be the measure of SPA, the arc SPA. Okay, the last theorem that we're going to talk about is what happens if you have a chord and a tangent line making an angle together. So if we have the chord AB and the tangent line BC, what if those intersect to form this angle ABC? Well, what would that angle be? If we look right here, it says the measure of the angle is always going to be the half the arc, the intercepted arc. So this is actually very, very similar to an inscribed angle. Okay, so this arc, A, D, B, that was bad. Let's try again. A, D, B. That's the best I got. Okay, so the arc ADB is going to be twice the angle, or the angle is half the arc. So let's give some examples. So let's go ahead and say if, let's make up a number. How about, I don't know, 300. Okay, let's say that the arc ADB is 300 degrees. What would the angle measure be? Well, if the arc is 300, we got to divide the arc by 2. So 300 divided by 2 is 150 degrees. So this angle would be 150. Let's look at an example. This was an actually interesting one. It says the measure of ABC, angle ABC, is 125. It's telling us the angle on this one. So we're actually going to work backwards on this. Okay, so first I want to find the intercepted arc. So the arc ADB. How do I find that intercepted arc? Well, if I know the angle, we just multiply the angle by 2. So 125 times 2 gives us 250. So the arc, the intercepted arc, ADC, or ADB, is 250 degrees. Okay, the other arc, AB, well, I don't have an angle there to tell me to multiply by 2 to just find the arc, but instead, if I know ADB, which is the other part of the circle, is 250, I can find the rest of the circle because they both have to add up to 360. The whole circle is 360. So I can just say 360 minus 250, and I get 110. So this angle, or this arc, AB, has to be 110. Okay, we do have an example on the homework that looks like this. This is saying the measure of arc MO is 130, so this arc right here is 130 degrees. So I want to find the measure of angle MOP, this angle right here. Well, again, the intercepted arc is 130, so the angle is just half of that. So 130 divided by 2 gives us 65 degrees. Okay, that's it on these angles, the inscribed angles and the central angles. Good luck.